Hello.
Hi, I'm sorry, you
No,
guys.
no, that's okay. Can you hear us?
Yes.
Okay. We can hear you too.
I have no idea why sometimes my Google Hangouts just doesn't work. But anyway,
Yeah, we're together now.
yes. Welcome back. I think we'll see each other a lot this month, but I think it's actually really nice to do the problems close together because you see how they fit together a little better.
Agreed.
So Bowen wrote me that he didn't have any grand plan in mind with those numbers that he used. But the next day he wrote me again and said, well, I think they might show up again later in the course. So if nothing else, he just likes those numbers for a variety of reasons, and you may see them again. So it's good that you're like, why this? In the meantime, you can just start, if you haven't already, on the opener.
Awesome. Thank you.
Yep. I don't know. Have you guys already started?
A little bit. We've been getting settled.
Okay, great.
This is from last year, though. Happy Difference Day.
But we're still synced up, it's still in a week.
Yeah. But it doesn't equal 19.
Right.
But yeah. So I have to remember what. It's the conjugates. It says it's the reminders there. Oh, thanks.
Also, you guys, it will be useful if you can keep these in some kind of organized way.
We were just talking about that.
Okay, good. Sorry, I didn't hear you.
So we have a folder, but I wouldn't call it organized.
You don't, I mean just this.
A table.
Data. But yeah, it's great. The folder's great. It's better than nothing.
Oh, we need some calculators.
Yeah, I got about 5.
Okay, I just want to make sure it's safe.
And then did you square it?
Square 5?
No, that.
Oh,
I
3
got
plus
it's
4?
like 3, 4, 5. We were doing this last time, I like controls.
Oh, you're right. Wow, that's great.
Hey, isn't this the whole thing we did last time?
Well, I didn't remember knowing. It's just, give me 5 more minutes and then I'll say, oh, I see what's going on.
Abby, I just sent you the link to the spreadsheet. So if you want, you can put this in the spreadsheet too.
Oh, I like that idea.
Then you can find it again if you need it, just in case.
Maybe this is the
second, maybe 10? Yeah,
that's pretty good.
Because it's double the first. 1 is half of 3 plus 2, 5. Don't tell me. Yeah. Oh. Don't say it. That's it. That's it. Let us think. I may have owed you.
I didn't say anything.
That's the basic arithmetic. Oh yeah, there's a calculator if you want pattern somewhere.
Yeah, really?
Turn the bottom door. It's not.
Where's this?
I think it is. I got it. No. Or computer's different, but this device.
Hey, do you want any sneakers or no?
Those are mine.
Here, I wear shoes and. Yay.
I think I have all the new ones, but I don't remember.
What?
Did you guys find everything in the opener?
No, we need a little more time.
Okay, take your time. No rush.
I'm gonna start recording. Where in the spreadsheet, should we put this in the shared workspace or should we put it in our Baldwin? Oh, use this in the Baldwin one, right?
I would put it in the Baldwin one, yeah, so you can find it easily. I mean, I've kept the 3, 4, and 5 spreadsheets together, and if I had to do this again, I would just make one spreadsheet for the whole course so that you could, so everything was together.
Yeah, I can see that. I agree with that. In the table, is there value of showing like the intermediary steps, or should we just show the answers?
I think you will do so much of that intermediary step stuff today that it's probably not worth it. Just make sure you have the number, the square, and the norm.
I got it. I'm gonna give you, yeah, do you want to compare and see if which one I got wrong?
I'd be like, just. Yeah, you can do that. Sharon, I'm sharing.
Wait, like 2 more minutes. Or the same thing you have. Just a little more organized. Sarah, can I text these to you?
Yes, go ahead. That would be great.
Sorry, my phone was off. I'm realizing.
No, that's okay. Just like, oh no, maybe they can't get Zoom, which was in fact true.
Yeah.
Yeah. So we have the calculations, right? Should we read them out, make sure we're all good? Try and I checked. Justin, you can say
I did mine. Yeah, I just keep too. Plus, I did all that crap with 11 the other time, so I feel like I'm owing some calculations.
Do you guys think that you have them all right?
I think so. So we have, Shauna, do you mind if I read these off?
Yeah, that's fine.
Alright, so your pairs are you just weird. You never know. Okay, so the first one, the square is 3 plus 4i
Uh-huh,
is 5.
uh-huh,
The next one, the square is 8 plus 6i, the norm is 10.
uh-huh,
Then we've got 5 plus 12i, the norm is 13.
uh-huh.
So I feel like I'm noticing 5, 12, 13.
Yeah.
We got 3, 4, 5. So I'm just trying to make those a different color in our spreadsheet. It's 6, 8, 10. Yeah, 3, 4, 5. I was like, it's not about 6, 8, 10.
What about 15, 8, 17?
Yep, 15, 8, 17, 21, 20, 29, 30, 33, 56, 65,
Mm-hmm.
55, 48, 73, 209, 120, and 240.
All right. So my New Yorkers, how can you generate Pythagorean? Please describe a method for generating Pythagorean triples.
I'm so ready. Can I answer that question?
Yeah, go for it, Joseph.
So for any two integers, a and b,
Mm-hmm.
if you find the product of a and b, you get a squared minus b squared. Sorry, for any two integers a and b, right, you can make the complex number a plus bi. When you square a plus bi, you get a squared minus b squared,
Mm-hmm.
2abi.
Mhm.
Say that one more time.
Yeah, if you take a plus bi and you square it,
Yeah.
you get a
Oh,
squared
yes,
minus b squared
yes.
plus 2abi.
Yes.
So a squared minus b squared, that's like a number, call it x. 2ab, call it y.
Mm-hmm.
The x squared plus y squared is going to be the norm of a plus bi,
Mm-hmm.
which is just a squared plus b squared.
Mm-hmm.
So if I have any two integers, I know that if I use like any two integers a and b, I can use a squared minus b squared as one leg of the triangle, 2ab is the other leg of the triangle, and a squared plus b squared will be the hypotenuse for that leg. That's my problem.
Okay. For any, I'm writing this down in our notes.
I mean, I think there's just one tiny little point that is worth noting, that if you have negative numbers in your z-squared, will it still work? Because those negative numbers can't be lengths of a leg, right? You answered this last time, Jasper. You did that calculation. That's why I'm thinking about it.
But numbers will create different values if you're like going down like the squared path, right?
Mm-hmm. Mm-hmm.
And so like even though like initially they won't be helpful, they won't make sense for a triangle, if you square them all again, you will get new values for the complex numbers, because squaring in complex land, like negatives do funny things because of the I value.
They do. But as you're pointing out, once you get that z-squared, if you have negatives in that z-squared, you can just take the absolute value and use those values as the legs. But, that's the calculation that you did last time to check. I'm pretty sure.
Yeah.
Not, you might, I mean, the norm is going to be the same. So, okay. This is a big subject that we'll look into today, is looking at relationships between the numbers that you were looking at last time. I think that's a good description of how you can generate Pythagorean triples. Are you guys all on board with Jasper?
Yeah.
It's really nice, right? Like Bowen does these amazing calculations. Sometimes he's just chatting and he's throwing up giant Pythagorean triples. But actually, he's creating them with tricks like this.
That's pretty cool.
He's just come up with an amazing Pythagorean triple, but actually, he just did 15 high.
That's pretty cool.
It's cool that he can do it in his head while he's talking about pinball, but that's what he's doing.
So let me see if we want to change anything. This is how I wrote it down in our notes. To generate Pythagorean triples for any A and B, you can make A plus BI, where the norm is the hypotenuse and the square of A plus B produces 2x.
Mhm.
Good?
I mean, I think again, this is just a picky little thing.
Wait,
But you might use whole numbers because it's not going to work with irrational numbers in the same way, for example. I mean, you're not going to get what you traditionally think of as a Pythagorean triple.
Right.
But if you start with whole numbers for A and B, then what you said sounds good. But did you put those in the notes on the
I put
spread?
that in table leader chart.
Oh, totally. Great. That's great. Okay.
They turn off the heat in here when it gets this late.
Is it cold there?
It's cold.
I'm sorry. I'm really sorry. I can make you feel better by tilting my computer out my basement window, and you can see that we still have snow on the ground and quite a bit of it.
Yeah.
Okay, so we're ready to move on, right? Important stuff?
Could I say one more thing that I was thinking about? Just a small thing.
Yeah.
No.
All right. So on the first day, we talked about numbers that could be made from a squared plus b squared.
Mm-hmm.
Right?
Mm-hmm.
And now we know that if any number of those numbers, like wherever that list is of numbers that are a squared plus b squared, if we were to look at that list now, we would, since we knew what generated those numbers, then we could go back and turn those all into Pythagorean triples, right? Because we have a squared and b squared, and we know that the other two pieces are a squared minus b squared and 2ab. So that's like kind of sweet, right?
It is kind of like a meandering path, right? Because if you found that 5 was a squared plus b squared by brute force, then you found the a and b.
Yeah, that's true.
But
ask the question like, what things could be Pythagorean hypotenuse?
yes,
You're that guy.
that is exactly correct. Yes. That is actually a nice way to come full circle with that first problem set. It's
Cool. That's all I wanted to say.
okay. So number 2, and by the way, that's number 2. By the way, don't forget to look at Bowen's little note about don't just write it bigger. What are you doing? For number 2.
So when we know it's the norm of x plus b, so it's just x squared plus y squared.
Right. Well, this is what I was thinking for this statement. This statement that you're fixed, right? Yes, that's what I was just thinking for the
I was just trying to see if I simplify it, so if something cool, this or something. Oh, it's just like another way of saying it, right? X, Y, and Z. We know two, if we know A and B. Oh my God, that's really cool. I need to do it right. From here, we know.
Agreed. You can go something all the way back up the pyramid.
If you know A and B.
You already know that. That's cool.
It's something really cool. Yeah, sure.
I want 4 because.
Alright.
But that's why I asked for a compass. So 4 was saying to draw a graph where all the coordinates are findings within origin. So I did a circle.
That's great.
And mark all the integer ones, and it's like 0, 5, 3, 4, and then like what's the equation of the circle? X plus Y squared.
Oh, nice. That's awesome.
Wait, don't give it all away. Yeah, don't give it all away. But yes, that is really nice.
That is actually too good to
Mm.
We needed to erase that backspace. Because number 3 is find all 12 ordered pairs, so now I know.
That's why I did number 4, because I didn't want to do that.
I'll send a picture of this over to Sarah.
Don't forget to do number 3. Don't skip number 3 because it's nice too.
Okay, number 3. All ordered pairs.
Wow, that is a really beautiful circle.
Oh yeah, I have a compass.
Yeah, right. But still,
Like,
It's amazing how she selects
I was like, that was quick.
Yeah, I know.
Technology. I'm like, wow.
Yeah. It's basically, you're basically here with us, Sarah. It's weird. Okay.
Mm.
All 12 ordered pairs.
so easy when it's just one site. I can hear, I can see. That's great.
Oh, yours is not. Going back to something with the previous ones. Oh, man. Sometimes it could just crazy.
we can't fix it.
This is right at one of these lists. It's really, really interesting.
Today I got this confiscated in 26.
Oh, I think you
Were you stacking up kids?
No, my dad had to go to court for fraudulent. In my 6-year-old Hello Kitty purse, I carry a compass. I've always been this nerdy. When the security officer took it away, I started crying. And when I asked for it back on my way out, he said, "Why harder?"
Abby, did you just use the same compass to draw your circle too? Okay, that's great.
I want mine to look as good.
Then you better send me a picture so it's part of the research record.
Because you know how cheap these things are.
On the thing, the tool.
I know, I do, I know everybody's so cute. Okay, wait. Sorry, not you. No.
I was right on the other side.
Here's the dog. It's nice. I'm missing something. Oh, yeah, I read that. Oh, okay. Because this isn't the complex. Well, I think you're doing it in the same. Right?
Yeah, isn't that the exact same? Like your
That's
y
what I'm
value is
thinking.
I, your x is your x, and the y is just y.
Okay, that's what I thought.
I am not.
Okay.
Can you put, do you want to, this is important. Do you want to just say something about, like, Jasper, why is it the same? Or Abby, why is it the same?
What is it?
Or at least put into your notes that you think it is the same, even if you don't want to say exactly why. But keep that there somehow.
So I think when we found all 12 ordered pairs,
Mhm.
that we were using that same thing, x plus the complex number,
Mhm.
to figure that out. So it's like, yeah, I'm trying to figure out how 3 and 5 are asking different things.
I mean, you're in a different plane, so you're not saying that 3, 4 is the same thing as 3 plus 4i, right? But when you actually draw those on the complex plane, the picture looks the same,
Right.
right? Because you plot the complex number the same way that you plot the Cartesian coordinates,
Right.
because it is a Cartesian plane. It's just a different, it's right.
Right. Yeah.
I know.
Right. I feel like I'm either missing nothing or everything.
I think you're seeing everything. I don't want to make too big of a deal about this, but you're supposed to see, like, oh yes, this is a perfect match. And it's kind of the same thing as what Jasper just said with, look, if we're looking at these, this is the version of this for what Jasper said. If we're looking at the distance from the origin, right, the distance which is what defines that circle, right? Yes.
The
right.
value of complex or real numbers.
Word.
That's it.
Oh, sorry, yeah, I didn't mean to.
Okay, wait, I will take another picture.
Like you could rewrite 3, 4 as 3 plus 4i. And
Should
and
I
then
that
it-
the same thing?
I don't know, like it depends on how complicated you want your
Or how complex, how complex.
Oh!
But what Jasper said before is basically the distance from the origin of the 0.34 is the same as the distance of 3 plus 4i, right?
Sorry, can you say that again, sir?
What Jasper, one of the ways that you could hear what Jasper said before when you think about distance is the distance from 3 plus 4i to the origin is the same as the distance from 3, 4, right?
Yes.
All right.
That's
Circle
seems-
is x squared plus y squared plus 25.
Yes. All right, go. Keep going. 5. Abby, I can't wait to see your perfect circle too.
Oh, I didn't send mine, I sent it just in one.
That's not bad. That's really nice. Was that like a test to see how good Sarah's like circling was?
Yeah. I can send mine.
Is she gonna say that's even better than insurance, but it's the same?
No, you know what? I was about to say that, but then I realized. I was like, wow, that circle is so amazing. Oh, and she drew in the triangles. Oh, you
Yeah.
drew in the triangles. Lovely.
So it improved.
All right, go ahead to number 5. No, you did number 5. Go ahead to number 6.
You get -5. You get -5. Oh, that's so cool.
It's like a 90-degree rotation.
I'm happy if I know. What's that? I'm really writing over there.
Okay, so I should probably do number 6 in that case now. Okay, don't tell me,
It's right over.
maybe you two should talk and Shania. Understand.
No, I wasn't even talking about it. It was just, I was just like a brain.
Okay.
Totally agree. Feel like you crushed number 9. I didn't even know that was there, but I totally agree with you.
Yeah.
Crushed it.
Okay, so 6 is just like just adding this squares. It's exactly.
I think they just want you to show it algebraically. That's what I saw. Is that it? Yeah. I don't really know. No, I know that.
Ooh, right? That would work.
Why 212?
Outside 12.
Okay.
You're just gonna look for the coordinates you had.
Well,
pretty
for
dope.
B, so
And like, yeah, I do. Go ahead, go ahead. No, I think you're good.
I thought that A was.
You could-
missing something.
What happens if you multiply?
I think the fact that you know A and B is 5 and 12, that's okay.
She wants to find all of them, she's not.
You want to
catching
find
up.
it all. Gotcha, okay. Cause then B is like a little bit weird.
Well, I also wanna see what happens if I drop, so, I mean, it'll just be a small answer.
One finding that we made last time was that the norm was multiplicative, which was a word we made.
That's not made up word, that's
Oh,
not
right, right, it's not a word we made up. And specifically, right, that AKA, that the norm of potentially what Abby's calculating is the same as the norm to the smaller guys.
Multiply together.
Yeah,
Well, let's see if that's right.
I thought we thought about
I
it, maybe we
remember.
didn't, it feels like we had a conversation. You should do it over my notebook so that you can take the point and that's why it's like. If you.
And I think it's pretty expensive.
And you're feeling good.
Wait, how did you find?
65.
This is square root of five.
Square.
What happened? I wanna feel good.
Okay.
That was intense,
It
like,
was.
yeah, where's the
Well, I just had a
AEDs?
moment, I had a moment. Okay, well, I just did what 6B said to do. And I got this weird number. Do you want to know what I got when I calculated the norm of A plus BI times C plus BI? No. We should do it. We should do it.
I know, but first thinking about the norm. Sequencing.
I can choose one or two. Is that chill or no?
That's chill, I just didn't think of
Five is 3.
it. Because it's square root.
Oh, this is even more sense. So wait. What is your A and B? 5 and 12.
Yes. Chill.
But that's because 17. 3 plus 2 is 15.
Product. Where's the product in the chicken?
It is this
Sorry. Wonder if the product shows up in this drawing.
You know about this
Use
notebook?
Desmos?
You know how to use this notebook?
Oh, I don't want.
Do you want to use Desmos? The ultimate fancy?
But there's no way they're gonna intersect, right? Because that radius is so tiny.
And figure out if there's a way to associate that.
So what do we do?
How do these work? Do any of us know?
Yeah, you put, where your right hand, don't you put a pencil in?
Right? Okay. Good. Right, 6 feet.
Oh, well, can I go back to 6A? Did you get 5, 12, 3, 4? For A, B, C, and D?
5 and 12, I got 5 plus 12i makes 13, but I got 2 plus 1i makes
When I look at this, so I looked at my chart and
Yeah.
said, when the norm is 13, that's 3 plus 2i, so 3 plus 2i gives me 5 So
Word.
5, 12, 13. So when the norm is 5, I'm looking at, oh, that's 2 plus I, so 2 plus I squared is 3 plus 4.
Wait, I think you're going too hard. Remember, what was cool about what we did here was that 3 plus 4i, 3, 4, 5 is Pythagorean triple.
Right.
But it's not the case. If you just want something with a norm of 13, you just need this original thing, 3 plus 2i. That has a norm of 13. 5 plus 12i has a norm of 13 squared, which is 169. But you just want a norm of 13, not 13 squared.
Yeah, that's why I did 2, 5, 12.
Wait, okay, I just want a norm of 13. But why wouldn't I use?
3 plus
Oh,
1.
I want a norm of 13, so 3 and 2.
Yeah.
And so why do we use 5 and 12? 5 and 12 is just another thing that gives us the norm.
5, 12, 13.
5, 12, 13 is Pythagorean triple.
Right, okay, we're just curious about these numbers. So it should be 3, 2, 2, 1.
Yeah.
C and D, A, B should be 3, and B should be 2, C, 2, D, 1.
Yeah.
Oh, everything I got is a square from what I should have, because I did the other thing.
Yeah.
But I sensed that it might be a square, and that was my wrong thing, but I was actually wrong. Yes,
Yeah, that's what I said.
yeah, so if you take the norm of each and multiply it. Same as if you took the norm of, I just multiply. Yeah, you're discovering lots of, now I understand it. Okay. So thank you for helping me do that. So once.
So sorry, what did you get again? What did we say?
Well, now,
Oh, snap. Oh, snap. This is kind of cool.
I have to read it.
Right, the triangle, 212, process that.
Wait, can you tell us?
That
what these
can't be
are?
right, can it?
Tell us what these are.
So this is the circle for the normal 5. This has a radius of square root 5. Right? And then this one has the big one has the 2 and 1. Well, 2 and 1 is the point that I have here, right? And then that's 5, 12.
2, 1,
Is that,
12.
wait, too excited? Is that wrong? That's right.
Wait, tell us more. I just don't understand it.
This circle has, this is supposed to represent the norm of C plus BI equals 5. This one is A plus BI equals 30 norm.
Okay.
And so I, like, just like with the other one where I drew the bow tie, I was trying to draw the bow tie here with 5, 12. And then when I did it in the little circle, it's
But
1,
1, 2 isn't similar to 5, 12. 6, 12 is similar.
yeah, 5 seconds.
The 1, 2 is,
That can't be right?
1, 2 is the A and B value that gives you the 95.
Sure.
That's what it's.
You're just right.
So it's just fitting the figure.
But no, you're right. In
It's
terms
not,
of
it seems
geometry, that
weird,
shouldn't
that can't be right. Maybe your line, like, it's like too small of a difference or something, you can't tell.
Wait, why should it not be right? I'm feeling like it feels good.
Because if you
Because
draw
the
a
triangles
triangle,
aren't similar.
like, if you just think about the slope, like, the slope of the bottom thing is going up 2 and over 1.
Yeah.
But the slope of the other thing is going up 12 and over 5. Those aren't the same slopes, that's all I'm trying to say.
Yeah, you're probably right, that's so small.
It's just like the difference is kind of tiny.
12.
That would have been so small.
Oh.
That would have been so cool. Wah, wah, wah. I should just.
You should make the 5, 10 circle. Okay.
Great. You guys, it's great. It's
So. Cool. I was really thinking about transcripts.
No.
I want to see multiplication in the. Maybe use decimal so it's 1%. Compass that. How much more
I
precise?
really
Because I
like that.
really don't like those. I don't know. I should.
I actually, we have nice ones.
Well, you know, like the Sadler ones, where all those moving pieces, those also I don't like. There's ones from MatHead. They're like super simple, it's like this.
Oh, which
But
is
like, this isn't annoying.
okay, cool. So
I guess I don't need to do 36 again. Just say.
I wanted to do it for 7.
You just did 5 times 30.
Well, I did it with the wrong numbers, so I.
Right, so you got the square, you got 6 times square.
Saying something as a norm of something is not saying that its triangle is a hypotenuse. If I say the hypotenuse is 13, it's not saying the same norm is 13. But the norm is a squared plus b squared, but you're not taking the square root. The hypotenuse is the square root.
But isn't the hypotenuse this 13?
Yeah, I'm just thinking about 6 compared to 7. Right? If the norm of Abby found something whose norm was 65 when she multiplied a plus bi and c plus di, right? But the norm being 65 is not the same as saying the hypotenuse is 65 of those two levels. Right? Are you with me
When
on
the
that?
norm is 13, that's the hypotenuse of the 5, 12, 13, of whatever you
Yeah,
take
but-
the norm of.
But
I know
the
you're saying
Pythagorean triple is 5, 12, 13. This is the thing that Abby was asking before, but the norm of 5 plus 12i is 13 squared. It's not
Yes.
13.
Yes,
And
That's
so
what I
like,
think
and
that-
so this is what we're like, I just mixed up, but I think you were also maybe being confused by it as well, right? Like, there's a big difference. I mean, it's a small difference, but it's not the same. It's like the norm of 5 plus 12i is 169, 13 squared. Right. But the norm of 3 plus 2i is 13. But 3, 2, 13 is not a Pythagorean triple.
Wait, Jasper, in your opening chart, didn't you get, you had 3 plus 2i as z, right? And then you had 5 plus 12i as z squared. And then you had the norm as 13, right?
Yeah.
So I think what you're saying is you're not, is this correct? You're maybe, yes, I think what you're saying is right. You can't just go from, you have to be careful about what you're doing. But the z squared that you get actually does make up the Pythagorean triple, where the norm is the hypotenuse,
Right.
right? But that is a little bit different.
But like, I think I'm confusing myself because 6 and 7 and 8 are toggling between hypotenuse and norm, so then I started conflating them when I shouldn't have been. I guess that's all I'm saying.
But it is the reason that, yes, the toggling is happening and you do have to be careful. But that norm is the hypotenuse of a right triangle.
Yes, if you do the b squared minus a squared and the 2ab thing.
Yes.
All right, yeah, I'm feeling good again.
Okay.
I feel better.
I don't know how, Shauna, you look like, how are you doing over there?
Okay, 6B, I got 65.
Uh-huh.
I didn't get 65.
You
I
did
know I'm
65 square.
I know I'm supposed to get 65, but now I'm like, we go like for A, I got 3. I know I'm supposed to get 65. A, I got 3, B, I got 2. So then I took the norm, so I multiplied 3 plus 2i times 2 plus 1i. That's 6 plus 7i plus 2 squared. I got 4 plus 7i. Then I took the norm of that, so 4 plus 7i times 4 minus 7i. And I got 28. Oops. So we're trying to get 16. Thank you. So 65, yes. Oh, 65, hello.
By the way, does it matter? Does it matter which, if you have that the norm of a plus bi is 13 and the norm of c plus di is 5, does it matter which choice of a plus bi or which choice of c plus di you make?
No, because I already messed that up on the other one.
Also, was it this group or was it Nantucket? Did Jasper last week believe that the norm of the product was the product of the norms?
Yeah, Jasper was loving that rule.
So,
No, I'm sorry, I was also loving.
all right.
Okay, but so use the results of problem 6 to find. So that's, this is what you would do.
Yes.
There's some
Circles from that.
You're in your own circle.
I am. You realize thinking about fake geometry.
What did you say?
Just like.
Okay,
This face.
oh, I see, so I took the square of 7 plus 4i and I'm getting 65 plus. Is that
Say it again.
So I was like trying to answer 7 and I did that same mistake again where I just looked at what we had taken the norm of, so 4 plus 7i, and I squared it.
Thinking good.
I get 65 plus 56i.
That's good.
But they're asking for the hypothesis.
No, you're right, but remember 16i squared is minus, so it's 49 minus 16.
Oh,
So it should be 30 something.
so I wasn't making that mistake.
I think you're good.
Okay, so,
Yeah, I got that too.
what are you thinking over there?
I got that too. You're totally good.
Oh, my circle is not gonna work.
What?
Your circle totally works. It does. It just might not work exactly the way you think. It doesn't work.
It's where my teacher saying norm of 17. Like,
That shit sucks. I'm just 4 and 1. I like that. And all the things.
I don't know.
Norm of 17. You good.
No, but I'm not gonna make a circle using the point 815.
Now you gotta use the point before 1.
Right, I'm trying to, that was wrong too, the other circle.
Alright. Don't get down on the circle treatment of life.
Oh, this is gonna be a really annoying circle to draw.
So you can make any mistakes.
Abby, find that. Yes.
You subtract the squares that you do.
Yes. 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 And then the other one we just square.
Was it just 65?
Yeah. Sorry, I'm thinking about, you're thinking about shortcuts for this, like how to think of this in this way.
Oh, just right. Find A, B.
Yeah, yeah.
find the triple.
So you want to.
Yeah, what's tricky is like, I was thinking about that point too.
Square
3 is
Yes.
18, not 17.
Square and subtract.
So like so damn close. Yeah.
Square and subtract, let me see. Square and subtract.
But I don't know another way to do it. Like, are you gonna check every x squared plus y squared to try to get to 65?
One leg, so it doesn't even matter.
Alright, good.
Square and subtract.
Oh, yo.
Yeah. I really like that.
Are you working on 8
Seven, no, Sean,
or 7?
Sean just has like a new way to say how to find the figure triples.
To find the legs once you know the hypotenuse,
Yes.
Say it. Can you say it?
you square both of them and subtract and find the difference.
Uh-huh.
The other leg, you multiply them and then double it. Oh, which makes sense with.
And that's starting from start from A and B.
Square both and find the difference. The other one leg is multiply them and double.
Mhm. Mhm.
And that's when you know the hypotenuse and you're starting from A and B.
Mhm.
I mean, you could do it without me. Then you just have to do the last step. Hypotenuse, which is the square. Some of the squares.
Okay, nice.
That really helped me to hear it that way as opposed to like seeing it that way. What else should I write down in our notes? We've confirmed from last week that the product of the norm of two complex numbers is the same as the norm, the product of both norms. The norm of the products. Trisha is working on circles.
That's it.
Jasper is working on
Number 8 is like really challenging.
number 8. Anything
We
for the
just
notes?
finished 7.
Sean and I just crushed number 7. How do you do? And then I'll put that. Oh, wow.
Different ones.
Look it up.
Take a break.
Yeah, maybe. Do you mind if we, well, let's take a break at 6:30. 6:30 break? Well, it's 5:30 for you? Yeah?
I'm getting totally crushed.
Let's do 15 minutes, you guys. I think we're supposed to. So how about 35?
Okay. Okay, so, do you want this?
Yeah, I think she said take a break now for.
Wait, take a break now?
Oh, you want to take it at 5:30? Sorry, I thought you said, can we take it?
Yeah, maybe in 5 minutes.
You can do it whenever you want. I'm under orders to make sure you guys get 15 minutes. So we can start the 15 minutes whenever you like. Do you want to work for 5 more minutes and then take it?
Yeah, we'll work.
If you can get through 8 after just having done 7 or some of 8, a little bit of 8, that would be great. That would be a really good time to take the break.
Oh, there's gonna be a pass. There's gonna be a pass. I think the number of orders.
Yeah, I'm bugging out though.
So you get 12 or 25, right?
25?
Oh,
You're on number 8?
no, so when we had, so 12 words, so the number of pairs is what we're counting.
It's cool.
And we had 12 for 25.
So for the norm of 25, there were 12 over.
A norm of 25.
Yeah, what was
Is
the-
someone making a table?
Yeah.
Oh,
Alright, I got 8 for 17, and I wanna like put that down in stone.
Guys, no.
It's so silly.
okay. Let me throw this to the back.
Is it also 8, 15, 17?
8, 15, 17.
Yeah.
8 squared,
Agreed.
Right, so they're saying like 12 or 25.
12.
But the triples were also there.
Well, 25.
65, I totally burned out counting. Because the negatives go wild. They're like totally reckless.
Well, isn't it symmetrical or something like that? Like, can
My
you,
photo is symmetrical.
can you just count how positives? Yeah, just by positives.
So this was actually, you can 5 this way, 4, you actually get 3. I wonder if that is related to
Jasper, why do the negatives go wild for you for 65?
Well, 65 you can make with 8, 1, or 4, 7.
Mm-hmm.
So are there just 8 of each of those and then 16? I guess. Does that make sense to you?
Did you write them out for 5? For 35?
Yeah, I did write it out. Yeah.
Because it's all like, you know, symmetrical, like 3 squared, 4 squared, negative 3 squared.
Alright.
So it's 2, well, this is gonna help us with our pattern, right? It's 2
There's
times
2 different
4.
ways to get there.
Well, there's 2 ways to get there, so that's 2 ways.
It's 4 times 4.
It's not 4.
But why isn't it just 2 times 8? This is why I was getting upset. See, this is horrible.
Okay.
But wait a minute, is there an extra one here, because this is, because you have to also count.
Yeah, but the 0-ish is like the negative sign.
Well, there is no for 65. For this one, it works.
There's
for
3.
25 is the
3
first one.
times 4.
I guess I would argue instead that the 3, 4 is making 8. Because you flip 3, 4 and get 4, 3.
And then you add.
Yeah, that would be my claim. Whereas with the 65, you have 4, 7. This is gonna make 8 because you get 4 from 4, 7, and 4 from 7, 4. And then you also get 8, 1. You get 4 from that, and you get 4 from 1, 8.
And then add, do you add these 4 too?
No, because there's no
because it's
0,
not perfect
guys.
square.
But it said 12 complex numbers. I have 12.
For 65?
That's just because 25 is. That's
Oh, we should do it right now. Give me another perfect square. 9.
Oh, no, 169.
Yeah, there you go.
Do that
Good, Shauna.
Oh.
169.
Such a big.
I
169.
not write it.
It's there. It's there.
Oh, it's on
It's
there.
gonna have a
Okay,
plus
okay,
four.
okay. Yeah,
It's
it's
gonna have a
all-
plus 4.
So it's, yeah, it's just added 4.
Wait, I can use Shauna's rule. If 169 is 13 squared, so you take the squares and subtract them. 12 squared minus 5 squared, you get 119. And you take the other ones and you double it, right? So you
Multiply them first.
5 times 12 is 60, double is 120. So I'm claiming 119, 120,
What you got?
169.
What you got?
Yeah, that sounds fun.
169, please. Thank you. But is there another way to make 169?
Well, let's back to 65.
So is
2 times 4 is 8, right?
So is it
And so 169 is gonna be 12.
No. 65 is 16. No,
Why was it 16?
Wait.
Wait.
1, 28, 8 and 1, 4 and 7, 7 and 4, times 4, got it. 60. So 4.
Yo, and 65 is the product of two primes. But 17 is prime.
Right.
And I bet if you take a number like 13, there's gonna be 8 ways to
Perfect. What's special about 65 now, Shauna?
pop quiz for Shauna.
What's special about 65?
13 times 5. So it could be.
Oh, did you say that? Okay, product of two primes.
That was kind of messed up.
I'm sorry,
It's cool, it's cool, it just wasn't messed up.
I was still calculating 60. Product of two primes.
And so once it's calculated for, is it also gonna be 12?
I'm feeling like it could be 12. Or 16.
So this works. The
No, I totally messed this up.
Yes.
How would
This
this,
is right.
how would this
119,
possibly?
120,
169.
Wait, what?
It's right. 119.
And we don't get this any.
What are you guys saying the triple is for 169?
169,
For 169, what are you guys saying the triples are?
119, and 120 are the legs.
Yeah, right?
I just realized we just had this debate like 30 minutes ago.
It just.
This is a triangle.
119, 120, and 169.
You're saying 119, 120, 169. Hold on. I just want to calculate it.
It is already checked. But it works with taking these. I mean, there's squares and triangles.
Wait, but this is a Pythagorean triple, right? That's not the same as the norm.
Yes.
We're looking for norms, right?
Yes.
So we're moving 13.
Yeah.
Back to my other circle.
This
circle.
is 5 and 12. 5 and 12 make a norm of 169.
Yes. But
So look at all the points.
Shauna's method does work for generating Pythagorean triples.
Okay, say it again.
Yes, your method does work, but in that case, it generates the wrong legs, right? For exactly the reason that Jasper said.
Right. All right, 8.
Because you're
169.
Wait.
What about 13 to 0? 169.
Well, 13 and 0, that's the easy one.
Where do you
And
get
0 times 4, so those are the 4. right?
Yeah.
That's plus 4. Then we've got what, 12, 5, 12, and 12. So that's times, and then we have 12, 5, and 5, 12, so that's times 4, so that's 8. So far we have 12. I already wrote 12 down.
What about weird numbers? Like 2 is a weird number. Because 2
squared? Oh, so wait, what are we trying to do here?
10. One circle is so
So
bad.
I'm looking for two numbers that I'm, the.
Sorry, I'm gonna go over this another time.
I'm looking for these two numbers, basically. This being
I'm gonna try and circle.
yeah, more power to you.
I don't know.
4 and 630.
Yeah, I think we need a break. We don't even know what norm is.
You're good. You're fine.
I should say, I don't. I'll send you a picture of what we have right now.
How many did you get for 169, by the way?
Well,
That's where we're starting.
so far we have at least 12. So we're not,
Just a little lot better, guys.
but it's enough.
Yes.
So
That's
Somehow I have also gotten pulled into the muddle. And I don't know, I don't think that any of what I'm wondering now is why haven't the other groups gotten muddled? Like, because it is a little, you do have to be really, really careful. All right. Thank you for sending the pictures. Let's take a break, but really take a break and we'll come back. But you guys aren't really muddled, right?
No, I think we're good. So I think
Okay, good. That's great.
according to my circle,
7?
7,
You said 7. No, you said that's it.
7:49. That's what I said. No, that's wrong.
I don't know what you're talking about. You're just-
7 something.
15 minutes.
15 minutes. All right. So we'll see you guys at 6:47 Eastern.
Yeah.
Okay, perfect.
Bye.
We'll pause you.
You can't pick me up because it's like, it was like within 3 hours just to Harlem. So it's like,
It
there's
was
no
insane.
way. So I was like,
It took me
I'm
2
going
hours to get
home.
home.
I'm
It took me
going
2
It
hours.
was like, oh,
I thought it took like 8 hours to get home. Okay, well. Traffic stories. Okay.
Okay, are you guys ready for, do you want to go back to 8 or do you want to just call 8 and go to the neat stuff?
I think we're
I'm gonna keep
really,
working on it.
I think some of us are gonna move on, some of us are.
Yeah. That's totally fine. That's fine.
Yeah.
Oh, yeah, Shauna, this is your problem. I mean, this was like made for you. Yay.
9?
Mm-hmm.
Oh, Shauna did this.
Mm-hmm. She did it. She did it.
I got you. I can do that part.
Guys, I got 12. 169 and 12.
You're good, Jasper. 12.
It's not what I would- Yep. Looks
Right,
like I already have that answer.
Okay, so Shauna, you've already done 9, right? I mean, you really did it already.
That's awesome.
Yeah, it's really cool. So you can either write it out the way this problem does, or you can just move on to 10. It's totally up to you.
I'm gonna move on. Yeah.
You want to break down the script?
Mhm.
How did you know it was on? Actually.
That was really easy. I just looked at your paper while we were on break. Yes, I did. I was thinking a lot about the multiplier fact. Remember how like 65 was that norm, that thing that I was norm of 5 and the norm of 13 being multiplied? So I was like, if something's gonna have a norm of 169, it's either gonna be its own number or it's gonna be 2 norms of 13 multiplied together. And I was like, the only norm of 13 is 3 plus 2i. But there's other norms that also have 13, right? Like 3 minus 2i or negative 3 plus 2i. So I multiplied out some of those, but every time it either gave me 5 plus 12i or 12 plus 5i, or it gave me 13 plus 0i. So across those two, I was like, this is all I'm getting is like the equivalent of like 13 0 and the 5 12. So then I kind of was over it.
And the 512 we knew from the circle. And the 512 we got from just knowing what the favorite did.
But we also got it from taking 3 plus 2i, which had a number of 13. And we did 3 plus 2i
that
times 3
was
plus 2i from the opener.
Yeah,
And we were like, we know that goes back to the chunks.
3 plus 2i, Okay, so you're gonna keep going to see where's the time,
Yeah,
or you want to, and you're doing, we're good with 9, or 10?
This is what we're just talking about.
no, I'm just talking about it. It's like similar. Does this square? That was the thing that Shauna and I, Shauna was like, we did this and it didn't apply.
I think that. I guess is how it works.
give someone one side. Yeah. Let's. Other method is circle. Got my desk list down.
Yeah, other method is circle. But the circle is a graphical representation. Yeah, it should always be consistent.
That's true, and it's still x squared plus y squared equals.
Yeah.
So then yes.
So ten, yes. I'm just gonna put tens as
Because
circle, verify. And then okay, so main number 11.
so he's like 12, 15. Right. I think true, it's like,
It's 24, 5, 12, 13, 15, 17.
it's like the first, are there other? Yeah, it's. Right, like 169, 119.
They're like the low ones, is, these are like where a
Single
value,
digits.
yeah, like a value of where it's
Yeah.
I think it's low. 1, 2, 5.
Just kidding.
No. So these are primitive, right? So primitive just means then they're not multiple, they're relatively high.
So like 20, 21, 29 is gonna be.
But it just means they have no common factors in between the levels. Is it still on?
Her voice is muted. Yeah. I don't know if she's muted.
So
Yeah. Add 119,
3 plus 5, that gave us.
Oh yeah, I skipped 816. But everything else is like, no.
So they're trying to say, find this number. I'm not sorry, find the hypotenuse where these are four different sets. And the hypotenuse is the same number. So why did they just say find a number? Find the hypotenuse n. Is that right? Like label the hypotenuse. That seems really not. Yeah. A lot of what we've been given are. I think most of these in the alternates of the cycle.
How's it going, you guys?
With the updates and pictures to show what we're doing about.
Yeah, that would be great.
Yeah. Shall we do it?
Yeah. Good for nothing yet. The best word. Yeah, which one are you on? I'm still on 12. What'd you do for 11?
Well, for 11, I sure would have. I was just realizing that like A should be larger than B. If we want to look at things, right? Because at some point in the process, we subtract the square from A square. So we should I just have a more of that.
We just want to make sure a squared is bigger.
So that means it's.
Oh.
Negative. Oh, you're right. Okay. A squared is. A squared is.
And I'm gonna write n squared. Because that's the thing.
Oh, yeah.
Yeah. And that's.
I am up for this. What's up?
So I was just sharing my thoughts on that this is a good version. A squared has to be bigger than B squared to avoid the index. So you're supposed to kind of like think about how to say this, right? 17.
Oh, yeah, I did that 14. You did that already.
And 14.
Okay.
12, I'm not thinking about primitive. You're not primitive, I sorted it. That's where I'm at right now. Still need time. I think it's in the guess. Two.
Like it could be 10.
That's where did that? It's true. And I crazy. What?
Oh, is it because you always have a 5 and a 2? 5 and 8 number. Why do you have to have 5? Or sorry, I'm multiple of 5. I don't know why you need to multiple of 5. Yeah.
26.
Oh, boom. 17. There's something in. So, it must be even comes.
What's it being 12?
This, you're
Could
asking.
you show me something that is not going right?
They're asking us to prove 16. And then it's good.
Wait.
Is one, and then why has.
This is 26.
Well, it's not
2410.
I don't know. So I look at my conjunctions and it's not, it's one, it's not. It's like 2, 1. There's no, so it's odd and odd.
Can we do
And
the
it's
algebra?
odd, and it's odd, yeah, I'm into it, and it's odd, and it's odd. It's something you like on it. It's gotta be fun. You know, 1, 2, 3, 5 is.
Definitely the other way to repeat it.
I mean, it's but 1, 2 square root 5. So square root.
Next description.
9 and the triple is 92 minus 36. Maybe that's like.
You want to
Leading
move
to
from
y.
12
On and on.
What do you mean you already got it?
No, I said why there's a 2 and
That was weird.
well, I just want,
I
one is.
know.
Let's
Right.
go with
Right.
it.
Do you want to see the algebra argument or no? You don't need- you
Yeah,
don't need the line. Shouldn't
But
be-
there you go. If it's primitive, it's not gonna be a I knew what you mean. Right, that would be the 1, 1. So it has to be the 1,
Do you
2.
remember? If you
Woo! It could be. I mean, it makes sense to us, but it could be like
This is
grasping it.
This is
But
the
it makes
great
sense,
and odd
right?
split.
Yeah.
This one.
1, 2
2
is the next
times
one.
n equals
C is
n squared plus
So
1.
we build it.
So these are both even.
First is multiply the numbers, square all of them, right? 1, 4, 5. No.
Yeah.
It's good too. So where is this? I still think
This
it's
is the
like
formula.
1, 2 squared. And I think it's these as a case. Yeah.
Mhm.
Right? Like if 1 is there and then 2 is even.
Mhm.
Creates our even.
And if these are both odd, the same ish
Yes.
happens, right? This is even.
Yes,
You're
okay.
doing
Yes.
odd minus
Yes.
odd and then odd plus.
So right.
Dope. Not even dope.
Nice. Right.
Wrote it. You're gonna send yours first. I don't need to say the here instead.
Going with it. Let's do it. Yeah, this is it has to, we just don't know. Very excited to hear what you're talking about.
Spin it up. Right, that's,
Well, is there more? Is that the only condition? We're trying some conditions, okay. So that it definitely does, I mean, probably the double is.
I definitely feel good about that, but we haven't
Okay.
covered it all if it's divisible by like 3. We only used the even factors.
So we're gonna give us one, or, which is, which number? We're doing 17, okay, yeah, I just wanna understand the question before, and then I wanna. I'm going to. There's 2 of the same, what looks like the same piece, but. Yes. Yeah, it's all the time. Is that intentionally blank?
Yes.
Oh, they want you to figure out.
Oh, I see.
I see the little funny. Yeah, that's great.
I guess.
Oh, this relates to what we were doing, Sean, actually. Number 16 words. So let me.
Yeah, 16 we got it.
This is 17. We don't know. We have ideas. We know the answer. We don't know the answer. So you know it's always a multiple of blank? Yeah. Okay. Product of 3 numbers. And we have an idea of where it's coming from, but not. I think we're still missing. So. I can't believe we haven't through all of these.
Yeah, this is pretty good. I'm feeling
like I've ever reached them. What was it usually?
tough.
Where, yeah, kissing my. I wasn't getting to me. But it also. With a group of dollars. Is it this one? Yeah. So why that? It is. They have their group of 16. Oh, yeah, they're just.
Actually, there's a picture.
I'm working on 17.
Did you guys do 13 by any chance?
No, I was looking at it. And I was like, oh, and that's felt really impressive.
I remember that was like.
It has to be higher than one.
We should be able to use this norm nonsense. Like the work from last week where it was like, remember how we got behind the negatives?
Oh, I have something coming up. That's interesting.
Couldn't you use Shauna's method for 13? Like, you know how to describe.
And we just did 12. Yes, we could. Thank you. So what Adeline figured out is that if you just think about even, making it not a multiple of 2, then the only way to make it even is if one of your only way to make it not the case that every number is even is that one of your numbers be even and the other one be odd. Okay, so if you're thinking about m
And the third one is
just that these m, so the original m plus n. Do you know what I mean? So m plus an I, 1. Either m is even and n is odd, or n is even and n is odd, right? And so I guess. Thanks for that. And so you need them to be opposites, and then you can use this thing from number 9 maybe to like be very clever.
in terms of proof.
Mm.
Yeah, but then I wonder, like, okay, so what's to say that if one of them is even, one is not, the square of an odd number is still an odd number. You're adding 2 even things plus possibly odd things, right? You could prove it by disproving the first 2 odds.
Wait, what do you say?
Oh, you can't have 2 even things.
I think it's easier to see like the first case when you're just seeing. To show that that doesn't work. Oh, okay, sorry.
Or no, you need to.
Oh, okay, wait, like when n is 1. It's not. Right.
You do. So
Because then we would have something in common, it would have to be.
Right.
and all the amounts will to everything will be even.
Right, so it's gonna
Can't
be
be
even.
one,
It can't be any odd, any odd. That's gonna result in this.
Oh,
I wrote out a few. I have something crazy about this town thing.
yeah, we want to see.
It's okay, but do you want to say anything more about this?
Yeah, I think we should really keep working on it.
So I just multiplied our 3 numbers, right? And I did all the math and I got n to the 5th times n minus m to the n to the 5th.
How
And
do you factor out the 2?
oh, I don't know why I did that. I just divided by 2. Okay, actually, that makes sense because I was like, well, I tried 1 and 2 to just test it and see if that would. So basically, I know that this number, well, really, it's this number is always divisible by 10, but I don't.
How do you know it?
I know it because I tried it a few times, and we already know that when you notice the factor, the common factor is 10.
When you multiply all
Right, so we already know this is true, and I figured out, I just rewrote it to this equation, and there's something about that 2 and 5, right? Exponents of 5. I don't know.
I have an idea. Do you remember last time when we were doing, like, where's the opener for problem set 4? We did the mod thing. Remember that?
Yeah.
And we did it mod 3, and then none of the remainders were 2, so that meant it couldn't be 2 or 5 or 8 or whatever. Remember that? What if we did that thing mod 5 and it was always 0? then wouldn't that mean that like it's always a multiple of 5? Would that work?
It was
Oh,
zero,
this is
not 5.
mod 5 because it's to the 5th, but how is it to the 5th power?
I'm not saying that's true, I'm just saying you'd have to test it out, you have to make
Oh,
that
like
a thing,
this power is
like
multiple.
what we did last time.
2 to the 5th is 32.
Yeah.
I'm just
But
saying-
mod 5, it would be 2. Is that
Oh.
better?
Oh. I'm not sure that the mod has to do with this. We had thought about, we were thinking, we know it had to be multiple of 10. From 16, we know it must be even. And then somehow it must also, there's also always a 5 or a multiple. And also
High factorization of 10 is
5 and
5
2.
to 2.
So we know 2 has to be in it. We can literally see that 5 or multiple of 5 has to be, is in one of them. So that gives us this. But we were thinking also, if it has to be a right triangle, if one side is 1, like your base case is 1, and then your other leg, it can't be 1. And that'd be this solution.
Yeah, we were talking about some idea of the base case of 1, 2, root 5. Because none of this works like an isosceles right triangle wouldn't be a primitive triple because you have 2 congruent sides.
That, I'm following all of that, and then somehow 10 is coming in. Well,
Yeah.
but this is weird that this is 2 and this is square root of 5.
Right, and we tried to like
That's
square
good.
stuff. Okay, let me take a picture of this.
Okay, just for string solving.
Mm,
Okay. And you were doing this, you were working here.
You were working.
Sorry,
AKA.
I didn't
Sean
know
did all
that.
the work.
I did not mean
So we're seeing a 5 in this, we're seeing a
Yeah.
5 in your exponent.
yeah.
There's something about, it's like an escape room. Where there's like, what's the clue that connects to these things?
It's
Yeah.
5!
Oh my God.
I forgot it.
Oh,
That's
okay.
Right, never mind, fuck
I
it.
just, wait, give us a clue, give us a clue.
I think the mod 5 thing is good.
Yeah, exactly. Make a minutes.
Oh,
Okay,
everything modified that. Oh, this is like the opener, wow.
Okay, wait, that's pretty good.
Wait.
Wait. Give me a breadcrumb.
When we did the opener, we looked at this,
Okay.
that time a long time
Mod
ago.
5.
Mod, this was mod 3,
Okay, yeah, that's.
Okay.
Mod 0, 1, 2.
okay, and we got a bunch of stuff. I don't remember what it was, whatever, pretend it was something like that, right?
Okay.
And so this told us that like nothing that was 1 mod 3 could be a solution to x squared plus 1 squared.
Wait. That's 1. Yes, because it's 0.
Because there are no ones
Right.
in this table.
Right. Oh. Okay, you know. Yes, there's no ones here.
So I was just
Got it.
thinking about when you multiplied your stuff before you got to the, if you like factored some, I was looking at m to the 5n minus m to the 5n minus mn to the 5, right? If you factor out an mn, you get m to the 4 minus n to the 4. Cool?
Just like I factored out 2.
And so I was hoping like maybe this is always a multiple of 5. Okay, and so then I don't know, you should check it mod 5.
It is. Wow, take a picture of that.
Yep, sending that over to you, Sarah.
You did take a picture of it, didn't you?
Well,
Oh, he didn't finish the table. Yeah, send it, send it. Oh my gosh. There are some days when I really wish Al Coco, who first thought of some of this stuff, was here. I wish you were here right now. That's amazing. Bowen too.
We made some real progress today, I think.
Well, yeah, you did. That's amazing, right? Like, I've just last week, it would never have crossed your mind to use a modular arithmetic table to do anything, right? And there it is. Useful.
That's really cool. Yeah. And we were like, that's nice last week. I don't remember.
You guys did not think it was that nice. I was so disappointed. But at least this week you think it's nice, right?
Yeah. Cool. Oh, that's cool.
Nice work remembering.
Yeah. I think that one of the
The
main
11th
things, like, I don't know, this happened to me at PCMI too. Like, I feel like if you can keep one of these main things of doing this math well is like keeping everything organized and knowing what is happening. Because right now I'm like a mess. I need like a definition paper of like norm. This is remember that word. Like, I still need that.
Can you check one?
I know, no, people did a lot of electronic notebooks. Did they do that your year?
A little bit, just a couple.
I guess just a few people
Just
did,
right.
but I could see how they were able to just be more organized because meanwhile I'm like, I'm not good. And I'm like maybe remembering something, but I'm like, I can't even find it, so I don't know when that happens.
But Abby, I think people go back to PCMI year after year, and I think that kind of thing happens a lot more in the second summer than in the first. I mean, the first you really like you're just trying to get some of the ideas, right? Like the second summer, you have much more. You're able to step back from it quite a bit more and think of things like, okay, I'm going to keep this organized so that because you know, okay, these things are going to connect. Or like Shauna looking for, like, why did he pick this number in C? I mean, he wrote me, it took him 24 hours to remember, oh yeah, that's going to show up again someday. So when you take PCMI the second time, I think you know, I know the way these materials work. Every number is going to show up again someday. But you don't know. I mean, I don't think many materials that you've ever worked with before work quite that way, right? I mean, you have to be organized in all of your traditional classes, but not for the same reasons, right? It's the connections work differently. But I do think that next week or whenever our next session is, it is next week. We'll start with having the groups work together to try to build a little record of the first 5 sessions. Like what were some takeaways from each of those sessions? So that's not going to give you everything you want with like, I need a definition of norm, but it will at least give you a chance to reflect on what's happened so far.
That's next week is with everyone.
I think not Oklahoma, but everyone else. So you guys will just have like, I don't know how much time. I'll talk to Bowen and see what he thinks, but sometime just working in your own groups. And then you'll have the memories of the other people too. So we'll do that in the shared space somehow when you record some of the big takeaways so that everybody has a collective memory, and that will other groups memories will inspire other things in you too.
Cool.
It's like, I think it's a good time because that's really like, we're halfway done.
Yeah.
So.
Good.
But I think if I were to do this again, I would not do separate spreadsheets for every session. Like that would help too, just to have everything in one, like everything that you had bothered to put up. If you had it in one space, I think that would be helpful. And even with the facilitators' notes and what you did in your spreadsheet, it would be good to have all of those together. I don't know, maybe I'll at least try to build something that's everything. I'll just do a copy paste for next time.
Yeah, I think even like an hour poster
like, I'm imagining like a chart paper that I take out each time, these are like names or something.
Mhm.
But it's hard, like you say, it's hard to know what's going to until you start seeing, you have to keep experiencing it to know what's going to work.
Yeah, I mean, I think that's right. But it's also one thing that's really different is even if there's a week, but often there's a month between sessions, right? So it's a lot harder to remember what happened 4 months ago than 4 days ago. So that's pretty different in this session. And that's why I want to do that review of some kind.
Cool.
All right. Good work, you guys, today.
We'll see you next week.
See you next week in Chicago and Nantucket. I think it will be great for you guys to reconnect with Chicago and Nantucket. It will be good to hear what they think of as important about this particular lesson because it's different, I think.
Oh, they got, yeah.
They did different stuff. They each did different stuff. So, however, the product of the norm and the norm of the products did come up in Nantucket too. So you're not alone. All right. Bye, guys.
Thank you.